Well, so now we have to discuss about the optical instruments. When we use this term optical instruments, we are basically referring to generating image on the retina. That is, all the optical instruments basically have eyepiece and that is the eye lens and the objective. But the main optical instrument, that is the natural one, gifted by God, is human eye. So regarding human eye, we have to proceed with the structure, and we will find that in the structure, the main components of the eye will be, one is retina, and other is optic disc, the blind spot, the optic nerve, which brings the signal to the retina, vitreous chamber, optical axis, and a convex lens. The lens is just in the front near the cornea, and there is a pupil and the iris. So this is the main component of the structure of eye. One important thing regarding the retina is that the persistence of vision of the human eye is 1 over 16 seconds, maximum and minimum 1 over 20 seconds. So we find that the retina will respond only 16 to 20 images in 1 second. That is what the normal human retina. So first of all, light will fall on the object, it gets reflected, enter through the lens, and then the image is formed at the retina. This sensation is passed through the optic nerve to the brain, and we come to know that we are seeing. That is the principle of seeing, observation. And retina will respond only 16 to 20 images in 1 second. If more than 20 images will come, there will be interference. So now we'll come to the main side, that is the figure shows the eye. Light enters the eye through a curved front surface, the cornea. It passes through the pupil, which is the central hole in the iris. The size of the pupil can change under control of muscles. That is called the optic nerve. The light is further focused by the eye lens on the retina. That is, image is formed on the retina, and we come to know that we are observing or we are seeing. Now the next point is the retina is a film of nerve fibers as shown in the figure and covering the curved back surface of the eye. So the retina contains the rods and cones which convey the sensation to the retina, which sense light intensity and color. So when we use this term intensity, we are referring to energy per unit area per unit time normal to surface, respectively, and transmit electrical signals via the optic nerve to the brain, which finally processes this information. Now next thing is the curvature or the shape, and therefore the focal length of the lens can be modified somewhat by ciliary muscles. For example, when the muscle is released, the focal length is about 25 centimeters. Now we will highlight on 25 centimeters. That is, if we keep the reading material just touching the eye, we are not in position to read it. Therefore, the reading material must be kept approximately about 25 centimeters away from eye. This distance is called the least distance of distinct vision. So 25 centimeters, and for normal eye, object at infinity are in sharp focus on the retina. When the object is brought closer to the eye, in order to maintain the same image lens distance, that is 25 centimeters, which I have just now explained, the focal length of the eye lens, which is convex lens, becomes shorter by action of the ciliary muscles, because ciliary muscles have the tendency of contracting and expanding when some energy is coming on the ciliary muscles. This energy is obviously coming in the form of light. Hence the name is optic. This property of the eye is called the accommodation, or very elaborately, power of accommodation. If we will highlight accommodation, we can say this way, that is, power of accommodation of eye will be infinity, because the normal human eye can focus the objects in the space. So we are in position to view the stars and planets with the naked eye. However, we are not in position to explain the physical structure. For that, we require the different optical instruments. Now, we come to the next process, that is, if the object is too close to the eye, the lens cannot curve enough to focus the image on the retina, and the image will become blurred. So we are not in position to see that blurred image. Now, closest distance for which the lens can focus light on the retina is called the least distance of distinct vision. Just now I have explained that least distance of distinct vision is 25 centimeters, or the near point. The standard value of the normal vision taken here is 25 centimeters. Often the near point is given the symbol D. So D stands for least distance of distinct vision, and its numerical value is 25 centimeters. If the object is about 25 centimeters away from the eye, we find that we are in position to locate it very clearly.